Hi everyone, welcome back to this channel. In this video, I'm going to show you a quick setup guide on how to utilize the dual source that's available in the PNA or PNAX machine. So if you have a situation where you have to drive, let's say S21 measurements on two ports, and you need another source to drive, like for example, a mixer, so you can utilize that two sources in the PNA itself. So physically, I have connected port 3 to Firefox, as you can see on the screen, which on the left side. And on the right side of the screen is how it looks like on a PNAX. So without further ado, let's go to the setup. So let's say you want to do a S21 measurements while we're pumping out a second source from port 3. Let's go with that. So first of all, let's set the measurements to S21, measure S21. And let's change the reference level. So it doesn't really matter whether you do this or not, but since we're going to do a measurement of S21 and also pumping out some signal from port 3, just go with that. And the next thing we want to do is to set up port 3 to be ready to use the source, the second source in the PNA. Let's go to setup, internal hardware, and RF config. So this is a block diagram of how it looks like on source 1 and source 2. As you can see, source 1 is here and source 2 is here. So it's connected to port 3 as of now, and we can actually combine it to come out from source 1 in the event where you want to do the IMD, intermodulation distortion measurements. So this can be done by just clicking here. And if you're in front of the PNA, you hear the click because this is a mechanical switch. So this is a setup where you do a combiner of two sources signal into one port out. So this is not what we want. We want the source 2 to come out from port 3. Let's go back there. So it's done. So this is just to make sure that the path is correct. Then we go to frequency. So we need to have a frequency offset option so that both sources are uncoupled. So we go to frequency offset. And let's source 2, let's turn it back to uncoupled, means that we can set the frequency independently from port 1 or from source 1. So there are a few selections of sweep type. So I'll drop it down. So you can see a linear frequency, power sweep, CW type, segmented sweep. So you can play around with it. There are different usage for that. For this video, we just want to try on power sweep or CW time. This is where you can set a CW onto port 3. That means there's only one signal at one frequency that's coming out from port 3. So we can start with power sweep. So you can see that we can add it here, the CW frequency. Let's say we set it to 1 gig. Number of points is where you would need when you want to sweep across a power level. So we can try both options, CW time and also this power sweep options. So for now, let's try power sweep, and you can see the difference later. So we can click OK. So this is done. And click OK, done. So let's turn that on so that source 2 is uncoupled from source 1. So how do we turn that on? Let's go to power and attenuator. So port 3, we force it to on because there's no measurements done on port 3 here. And you can see that we are sweeping from -10 to 0 dBm. So it might be a bit too high for that. Let's change it to -15. Okay, so you can see that there's a fluctuation on the Firefox, which makes sense because it does change from -10 to -15 as a sweep. So let's go to Firefox and see the measurements. Let's go to here. Let's increase the sweep time and change the scale. So as you can see, it's actually changing from -10 to roughly about -15. So that is what we want. This is how it looks like when we set port 3 to have a CW in power sweep mode. So in the events where you need to power sweep coming out from port 3, this is what you can do. So the next thing I want to try is to just a CW across time, and let's change that. Let's go to frequency, frequency offset. Let's change power sweep to CW time. So CW time again to indicate that that's the signal frequency that you can the pump out from source to. So once we've done that, let's go to power again, power attenuator. So as you can see, you can't change anything start and stop power anymore. So there's only one port power, minus 15. So this is how it looks like on the field fox. Just flat at minus 15. So we have to give a bit of loss there because there's a cable connecting between the PNA and the field fox. So what to do if you need the source to be pulse type of signal? If you have the options of pulse generator in a PNA, you can do this. Let's go back to PNA. Let's go to sweep and source control, because this is where you can change the pulse setup. And this is how it looks like in the advanced window. You can go back to basic also if you want to. It won't allow user to change the port where the pulse signal is coming out from. So let's go to advanced. Let's use standard pulse. So currently my pulse is 100 microseconds. Pulse width and pulse period is 1 milliseconds. So this is where you're going to change. By default, it's using source 1 as a pulse generator. And you can also change it to pulse to source 2. So let's change that to CW. And let's change this pulse 1. So where do we set this pulse 1? Because this pulse is actually determined by user. And you can actually do this here, pulse generator. So as you can see, pulse 0 is the pulse with 10 nanoseconds, delay of 215 nanoseconds. So this is how we do it, enable it so we can use pulse 0 in this event. So there are other things that you can set out here. It all depends on what you need, but for this quick setup, I won't go into detail on that. Yeah, after changing that, only we change this one so that you are able to utilize that. So pulse 1 is coming out from source 2, pulse 0 is coming out from source 1. We can actually close that. Pulse 1, pulse 0. So receiver A is ready for pulse measurements. But we are focusing on source 2. So this is the pulse 1 that we have generated from pulse generator. So from here we can click apply and OK. So in FieldFox, in backend mode, 0 span, which is time domain measurements. So we can see that's our sweep. Let's set it to microseconds level. And so let's set it to 2 milliseconds because the pulse period is 1 milliseconds. Let's change the scale so you can see that. Okay, and let's set the trigger. Video. Yep. So if we do the marker peak, so it's roughly about 15 dBm. Alright. So this is how it looks like. And of course you can blend in both power sweep with pulse. And this is how it will look like if you add on the power sweep. So let's go to sweep again, and sweep control, frequency offset, and power sweep. And so it takes back what we have set up just now from -10 to -15. So as you can see, this is how it looks like. So as you sweep, it's actually changing from -10 to -15. If you need it in your test, this is how you're going to set up. And again, if you want to preset everything, just go back to preset here. Right. Hope this helped. Thanks for watching.